Hello students, welcome to Sree Academy. So in this session I'll be starting the concept of CPU scheduling. So CPU scheduling is also known to be process scheduling. So scheduling already we have an idea, right? Scheduling means what? Dispatching of process. So what happens here? We'll be considering the scenario of multi-program environment. So if I take multi-program environment, our ready queue, the ready queue is having of the more than two process, multi-processes, correct? That multi-process. So most of the time the ready queue can have the several processes. When we have several processes in the ready queue and single core processor is there, now we need to pick one of the process from ready queue and assign for execution to assign with the CPU, correct? So for which we need to take the decision. So which process need to pick from the ready queue and assignment of the processor. The scheduling is not a new word to us, like the before this computer, the before employing into the computer system, it was there. It is a common word, like wherever industry where the people are working on something, scheduling is required. So the best example I could say assembly line. So in the automobile industry, there's assembly line, like the stages wise, like in this stage what are the things need to be scheduled, and the next stage what are things to be scheduled. The scheduling is a common word which already they were using, and the same word is used for the scheduling the process here. So scheduling means, again repeating, dispatching a process from ready queue to running state. That's the meaning of scheduling. This scheduling also, like this CPU scheduling also known to be process scheduling. Either you can say CPU scheduling or process scheduling, fine. Either CPU scheduling or process scheduling means same only. So you have to pick a process and schedule it, fine. That means we need to find out policy, we need to find out the different policies to pick a process from ready queue and assign to the CPU. That's the point you need to do. And one more thing you need to understand here, the scheduling is there, right? Scheduling is a fundamental function of the operating system. Every resource in the system must be scheduled before use it. You have to schedule before use the resource. It is a fundamental function of the operating system. So let's take let's understand clearly. Suppose this is a ready queue, fine. This is a ready queue, fine. So ready queue contain the more than one processor, P1, P2, P3, P4, fine. Now there is CPU, like the CPU, only single core processor, fine. Imagine. So scheduling means, see, so what is scheduling? The either process scheduling or shipment scheduling here. There are four processes in the ready queue under multi-program environment. So now we need to pick, we have to make a decision to pick one process among them, one process among the ready process and assign the CPU. This you have to CPU to assign it. Now here, please do understand, here, this is the point here, short-term scheduler, right? This is short-term scheduler. The work short-term scheduler only. So in the short-term scheduler, we are running this working in the CPU scheduling or process scheduling, you can say. Okay, this short-term scheduler has to pick. So because we need to implement the decision policies to under short-term scheduler only to pick a process. The short-term scheduler has to pick one process and assign to CPU. So which one you have to select, either P1, P2 or P3, P4, correct? So we need to take the decision, yes. So we need to have some policy. Policy indicates decision only, right? So different policies we need to understand, like different policies we need to state. So which one is suitable to pick a process and assign to CPU. That also depends on the environment. It will vary from operating system to operating system. Suppose if I say under multi-program environment, some kind of decision you need to do. Under priority based, if it is there, like time sharing system, distributed environment, based on this operating system, the policies can change, but we can work out the different policies, how they going to be select the process, so the suitable policies can be implemented on the operating system. I hope you getting my point. So naturally what happens here, pick one of them, like say, let's take suppose I pick the process P2, suppose I pick the process P2 among 4 and assign to the CPU, So you can ask question, sir, what order, what kind of criteria are you using to pick a process P2 for executing with CPU? Fine. So now please do understand, there are two things will happen here. We have to use some policies to pick based on some criteria. So criteria, so I am writing the criteria. Okay. So criteria for what? For selecting a process. criteria for selecting a process means your scheduling policies may use a criteria for selecting a process, like based on the some for one criteria I would like to say some of them based on arrival time of a process. So now onwards there are different terms I am going to use. I will be explaining these terms also. Please do understand, because this definitely is going to be helping us to solve the problems. Arrival time. What is the meaning of arrival time? The time at which process is loaded into ready state or main memory is the arrival time. This is a ready queue assume, right? The time at which process P1 loaded, that is arrival time. The time at which process P2 loaded, the time at which process P3 and process P4 loaded. Maybe all four processes might be loaded in the same time or a different time. The time I mentioned that is arrival time. So now see, I can put one criteria for selecting a process as an arrival time. Means I can say short-term scheduler, yes, among the four processes who came first. Arrival time is who came first. I can keep one criteria, yes, select based on their arrival time of a process. The process which is entered first, that you give first chance. So that's what one criteria I can use arrival time. Second criteria is a bus time. Bus time also known to be service time. Bus time or service time both are same. So later also we'll understand clearly, but just briefly I'm giving bus time, service time. Simply when you select any process and load it into CPU, now process P1 is running in CPU, right? Instruction, the programs are executed in the CPU. The amount of time taken by the process to use the CPU is nothing but bus time. Or you understand, the process P1 required how much amount of time to use the CPU is nothing but bus time or service time. So purely when it is spending the time in time spent in a processor, the time spent in CPU is nothing but bus time or service time. This also can be classified like if I include IO activity, that later we will discuss. So I can use a bus time as a criteria to select a process. Suppose if I use the bus time, among these four processes I can use a matrix like saying that use a lesser bus time process first. Suppose if I put a criteria, select a process who is having the least CPU bus time. So that is one of the criteria. And third criteria could be like priority. This priority. Suppose sometimes some environment may require to prioritize the processes. Means some certain situation may require high priority process only should run, lower priority process should run later. So this kind of criteria when you impose, yes, based on the priority we can select it. Means each process has its own priority, based on the priority value can be scheduled. So now scheduling the process, some criteria we are using, this criteria we are using to schedule the process. Schedule means like this, dispatch, take a process, dispatch it, fine. So I hope you are getting my point. So these are the criteria for selecting a process for execution. But you understand there are different ways we can select, correct? These are the criteria for selecting. Different ways we can select it. Like there are, so I am just talking about policies. That's nothing but scheduling algorithm. Just I want to talk. So as I mentioned, right, process scheduling, CPU scheduling means we have to schedule one of them. So naturally, what generally comes in mind, like many service based systems you might be observed, like suppose when you want to service to the people, like suppose there is some kind of service center, you want to service the people, any kind of service. But generally what kind of policy you impose to service them? So some majority cases we observed, right, first come first serve only, or first in first out. Suppose if you go to the banking system, there is a suppose if you are going to be deposit the money, so there will be queue, correct or not? The person who is sitting to take the money, he will be imposed the condition that like first come first serve, who came first, there has to be come in the line so that I can service it. So majority cases we do this system only, right? Like even have some other things also, depends on the application only. So now that kind of scheduling algorithms we need to apply under short-term scheduler to pick these processes. So that scheduling algorithm may use this criteria. Those scheduling algorithms or scheduling policies can use this criteria to pick a process for execution. That you need to understand. So now our motto is to now get into these policies. So we must measure their performance of the policies also. We need to measure the performance of the policies, like which one is good to implement in certain application, right? So this measuring the performance of the policies or the scheduling algorithm, we say objective of a scheduling algorithm. Sometimes metrics of a scheduling policies or scheduling algorithms. Let me write so objectives of scheduling algorithms. So let me write objectives or we can say metrics of CPU scheduling, CPU or process scheduling, CPU scheduling or process scheduling. So you need to understand clearly. So now this objectives, metrics means, what is the meaning of metric? Measuring something, right? Measuring something, like, so what is the measuring? A performance of this scheduling policies. And this object is talking about algorithm, scheduling algorithm. So previously I given, right, metric criteria for selecting a process, means any scheduling algorithm can use some criteria to pick a process from ready queue and assign to the CPU. That differentiation you need to understand. So any algorithm, any policy which you are going to use, the first criteria should be, and maximize the, so not first criteria, objective metrics, maximize the CPU utilization. This is the first thing. Second requirement is generate good throughput. And the third objective is to minimize under one, waiting time of a process. Let us understand clearly. And second one, turnaround time of a process. Turnaround time. So let me short form notate it, like WT is a waiting time. So turnaround time, TAT, turnaround time. And third one is response time, short form RT. So now onwards I'll be using WT, TAT or RT, you can understand. So these are the, and fourth point also, yes, these are the major objectives of any CPU or process scheduling. Yes, we should keep in mind. So these are the objectives need to be checked for the scheduling algorithm, scheduling policies, like whatever we are going to design it, fine. So we need to understand one by one what is the meaning of maximizing the CPU utilization. Maximizing the CPU utilization means what? CPU should be busy, right? So CPU should be busy, like try to make it CPU as much as busy, means you understand how much load and the processor indicate the busyness, right? How much load means all the time CPU is busy only, we can say yes, it is busy only, like. So CPU utilization, maximize the CPU utilization measurement meaning measuring the utilization means, like CPU, how much load on the processor, how busy the processor, you can say. So I can simply write how busy is the processor means how busy is the processor, or how load on the processor, load on the CPU or processor, same only, fine. This is what CPU utilization, fine. So CPU utilization is busyness of the processor, you can say. Good throughput. So we need to understand the throughput, right? We need to understand throughput. Yes, this is general term. You must have heard many times of throughput, like you might be calculated throughput of a system, throughput of anything, like. So general definition I wanted to say first, then we can see here. Throughput means the amount of work, generally measuring the work being done. This measures, like throughput measures the work being done, how much work being done. Suppose if I calculate my work efficiency, throughput of my work, like how many topics I have completed per unit of time. Suppose suppose if I take the 10 hours time, so during 10 hours time, how many topics, I need to say in topics wise only, how many topics or chapters I could able to complete, that is my throughput. So simply way, if I want to say, suppose during your preparation, like end moment of your exam, you will be busy with solving the problems, right? you will be solving the problems. If I want to say your throughput, if I want to calculate your throughput, how many questions so you able to solve it per hour, how many questions you able to solve it per hour, your throughput. Some that will vary, throughput will vary from student to student. Some student, they can solve many questions within an hour. Some student may take a lot of time to solve that particular questions, right? So that is the reason throughput is indicates the performance of the person or system. Here, so I need to talk about here, good throughput nothing but number of process execution per unit of time. Yes, so let me write number of processes. Number of processes, or we can name it as jobs also, right? Sometime, or tasks that are completed their execution, completed per unit time. So unit time could be 1 hour, 1 day, or 10 millisecond, 1 millisecond. So whatever time you can give it. So 1 hour mein how many process completed, 10 minutes mein how many process completed. So that's what throughput indicates here. So this good throughput should be there, because why these are the points we are imposing in the policy, because if we know our objective to design something, then we can work out on the solutions, right? Yes. So next point is minimizing these are the following things. Waiting time should be minimized, turnaround time should be minimal, and response time should be minimal. So what is the waiting time here? So what happens here? So waiting time generally, see, just look into scenario, ready queue running state. Okay, ready queue running state. So generally processes comes into system. Correct. One of the process we need to pick and schedule for execution. Correct or not? Other process, suppose one is running in a CPU, means others are waiting in a ready queue only, right? Other remaining process are waiting in a ready queue only. Yes, their waiting time should be minimal. Means like should not be a monopolization. Means the only one process using the CPU continuously, means other has to wait. So that waiting time of process should be minimal. That's our criteria we need to understand. Fine. Yes. Next looking into. So I hope you got the waiting time, and also further time also we can discuss about waiting time. But simply I'm saying, the process can wait for the CPU, or sometimes process can wait in IO state also for any resource or anything. So second point is minimize the turnaround time. So yes, what is the meaning of turnaround time? Yes, you stop and you can pause the video, you can think yourself what is the meaning of turnaround time of a process. Turnaround time of process includes the total time taken by the process to complete its execution, including waiting for the CPU and usage of the CPU and maybe required IO activity, all including. Simply I can say time interval between arrival of a process, arrival time of a process and completion time of a process. Getting my point? Turnaround time of process nothing but time interval between arrival time of a process and completion time of process. Other way you can say the time at which process is submitted to the system, the process submitted system minus the time at which completes its execution. Is the gap is there, that is nothing but your turnaround time. Suppose in the morning, the 9 o'clock the process is submitted to the system, assume that to the ready queue 9 o'clock, and the departure of the process has happened at 12 p.m. or something that, like completion time process 12 p.m. So now 12 minus 9 is there, this is your turnaround time process. But you cannot say that it is not like the 3 hours only the process has taken to use the CPU. No, it is include waiting time of a waiting also, waiting time, service time, both waiting time plus burst times of a process includes here. So I am repeating the statement for turnaround time. So time interval between arrival time and completion time, or simply you can say completion minus arrival or completion minus submission. Arrival, submission time both the same only, you can say. Fine, they should be minimal. So minimal means in which, suppose in a turnaround time, if you reduce the waiting times, so waiting times also present. If you reduce the turnaround waiting times, so total turnaround time also will reduces. So we'll observe clearly on this turnaround time. Look into response time. This is an important thing here. Most of the time sharing systems, it is essential. Response time. Response time means the time at which process is submitted its first request to the time at which is response is generated. So that interval time is there is nothing but response time only. You can write down the definition. The time at which process is submitted its request to the system to the time at which its response is generated. This is nothing but what? Response time. So another way, let me explain you. Suppose there is a browser, like you might interact with the browser application. So in a browser we have hyperlinks, right? The time at which I clicked here, so the time at which with a mouse pointer I click, to the time at which its response is generated. So another page, just it got open another page, like the gap you say, this is nothing but your response time. It should be minimal. See, when the response time is minimal, nothing but system is responding more to us, correct or not? So the classical example which I experienced, I'll tell you. Suppose one decade ago, like 90s, 2002-3 times, you understand the system nature, like I use it when the system, like Windows 98 operating system, and they must have something like the RAM size was 512 KB. Today RAMs are 4 GB, 8 GB, 16 GB. So that time which I used 512 MB, why 512 MB RAM, 40 GB hard disk. So you understand how the system response in those days, like. So when I took mouse pointer and click on some application, okay, just click on the application, so we'll get the pop-up, or when you click on application it get open, right? So like it took me like almost in terms of seconds or minutes, 1 minute, half minute or 1 minute time to open that application. Very slow. Just you have to go take the mouse pointer, click over that, so it get open slowly. Then again click some application, it will get open, like. But if you see today systems, the response ratio is more, like. See, the moment when you place the mouse pointer over any application, just click it, immediately the application get open, right? Means the today's systems are more responsive, means response time in which is very less. The time at which I requested, like the first request submitted, so it immediately opened, right? The gap is very less. But in those systems, response time is more, like response time were more. Getting my point? So try to reduce this response time also, like. So it means you understand, suppose, so something process I submitted, it may taking 1 hour time to get the results. 1 hour time is taking to get the results. So now it is taking more response, right? So most of the time sharing systems are expecting what? Minimal response time. So these are the primary objectives or metrics of a CPU or process scheduling. So this we need to ensure to satisfy that algorithms. So later we need to look into, fine. So I hope you got the point, all right. So in this session we have discussed the first purpose of CPU scheduling algorithm given, and some criteria for process selection over shutdown scheduler also we discussed, and overall this scheduling process objectives also we have discussed. Now we need to looking into policies, like different policies, like I could state, like you might be heard also, you might be studied in a semester, the first come first serve, shortage of first, shortest remaining time first algorithm, priority based CPU scheduling algorithm, round robin, multi-level queue, multi-level feedback queue. There are many CPU scheduling algorithm we have. So some of them we can discuss based on your syllabus. But just before addressing into those policies, scheduling algorithm, just I would like to understand some assumption. Let us understand some assumption for discussing this scheduling algorithm.